Welcome to the Nokia SR Linux Learning Essentials video series, brought to you by the Nokia Data Center Fabric Certification Program. This video explains how the system offers a secure transactional configuration method using the SR Linux candidate configuration modes. In SR Linux, a user who wants to modify a configuration must first enter one of the candidate configuration modes. Modifications are made only to the candidate configuration and do not affect the running configuration. Therefore, no specific configuration order is required. The candidate data store is maintained until the user either commits it or discards it, even if the user logs out. When committed, the configuration changes are copied to the running configuration and become active. The candidate configuration can be modified in 3 different modes. The shared candidate configuration mode is the default mode. A single candidate is maintained and shared by multiple users. A commit by a user applies the changes for all users. This mode requires coordination between users. The name default is used when no name is specified. The exclusive configuration mode is the safest mode. Only one user can configure the router at a given time. Other users are not allowed to enter the candidate mode and make changes to the candidate configuration at the same time. The private mode supports both concurrency and privacy. It allows multiple users and creates a distinct candidate data store for each user. When a user commits their changes, only the changes from that user are applied. This is the configuration method used for GNMI and JSON-based RPC modifications. Let us focus on the private configuration mode. To avoid inconsistencies between the candidate and the running configuration, each private candidate configuration is modeled as a pair consisting of a baseline data store, which is a snapshot of the running configuration copied when the user enters private mode, and a candidate data store, which holds the changes relative to that baseline. Here, when user 2 commits their changes, these changes are copied into the running config. The other user's baseline now becomes different from the running config. The system warns users of such differences by adding the exclamation character to the prompt. Then, users can manually compare, verify, and update their baseline from the last running configuration. Let's explore the candidate configuration modes with my DCF lab. First, the default shared configuration is the commonly used mode. All users share the same candidate configuration. Here, the default admin user and user Bob start candidate sessions on the same Spine 1 router. The admin user enters the candidate shared default mode and changes the interface state. When Bob starts its candidate shared default mode, he is notified about admin user changes and an asterisk is displayed at the prompt. Bob changes the BGP neighbor state. The diff command displays all the changes, both those performed by Bob and those performed by the admin user. Prior to committing, it is recommended to do a diff at the root context. A commit in any shared session applies the changes from all users without any warning except the removal of the asterisk from the prompt. Therefore, coordination between users is required to avoid configuration mistakes. Now let's look at the exclusive mode. In this mode, a single user is allowed to make configuration updates, and other users are blocked from making any changes at the same time. This is the safest mode, but it is limited to a single user configuration change. Last but not least is the private mode, which has many advantages. In this mode, a distinct candidate data store is created for each user. When a user commits, only the changes in that user's candidate are applied to the running config. For example, the admin user sets the admin state of the first IPv6 BGP neighbor to disabled, but does not commit. Similarly, Bob sets the admin state of the second IPv6 BGP neighbor to disabled, and then commits. Back to the admin session, the prompt now displays the exclamation character, indicating a possible conflict, but the private admin candidate does not change as shown with the diff command. To check the conflict, the baseline diff command compares the running config and the baseline data store that was created when the user entered the candidate mode. Based on those differences, the user decides whether the diff shows a conflict and modifies the configuration if required. Admin could use the command baseline update to merge the running changes into its private baseline data store. Admin should then either use or modify these changes before doing its commit. Let's now do some verification using the Info from State System Configuration command under the running sessions. Here, the admin user and Bob are connected, editing the configuration in private mode with the candidate's default name. That's it for SR Linux candidate configuration modes. Thanks for watching, and be sure to explore the rest of this video series to learn more. And when you're ready to practice what you've learned, my DCF Learning Labs provides comprehensive exercises with step-by-step instructions and solutions, all in one simple browser-based application.